Have you ever wondered why your smartphone doesn't heat up like a frying pan, despite all the processing it does? Well, it's not because of some magical cooling system, but rather a concept called low voltage logic. This is the principle guiding the operation of digital logic circuits with lower supply voltage levels compared to traditional logic families. In modern semiconductor technologies, reducing the operating voltage has become a common approach to achieve lower power consumption. This is vital because, let's face it, no one wants to be tethered to a power outlet all day. Low voltage logic allows for improved energy efficiency, making it a key player in the world of portable and battery-operated devices like your smartphone or smartwatch. But it's not just about power efficiency. Lower power consumption also translates into less heat generation. This is a crucial aspect as it contributes to better thermal management in electronic devices. Remember the last time you were trying to stream a video and your device felt like it's on fire? Yeah, not a pleasant experience. Low voltage logic helps prevent that. As we move forward with technology, we're continually shrinking the size of semiconductor features. This is where low voltage logic becomes even more critical. As these features get smaller, reducing voltage levels becomes essential to maintain reliability and prevent issues like gate leakage. In other words, low voltage logic is a key factor in enabling the miniaturization of electronics without compromising their performance or reliability. So, while we talk about more prominent aspects like processing power, screen quality, or battery life when it comes to our favorite devices, let's not forget the unsung hero, low voltage logic. It's the silent worker, ensuring our devices are energy efficient, cool running, and reliable. In the next few minutes, we'll delve deeper into the evolution, characteristics, applications, and challenges of low voltage logic. So stick around for an exciting journey into the world of low voltage logic. So the magic behind your cool running smartphone is none other than low voltage logic. Low voltage logic didn't just appear out of nowhere. It has a fascinating history and evolution. The journey of low voltage logic began with the traditional complementary metal oxide semiconductor or CMOS logic families. These were the workhorses of the digital world, widely used in microprocessors, microcontrollers, and other digital logic circuits. However, as the demand for power efficiency grew, especially in battery-operated devices, engineers began to explore how to adapt these traditional CMOS circuits for lower voltage operation. This quest led to the development of low-power CMOS or LPCMOS. This was a game-changer in the world of digital logic, allowing circuits to operate at lower voltage levels, reducing power consumption, and making them more suitable for battery-operated devices. But the evolution didn't stop there. Engineers pushed the boundaries further and ventured into the sub-threshold region of transistor operation. This region, where transistors operate at very low currents, gave birth to sub-threshold CMOS. Operating in this region led to ultra-low power consumption, further enhancing the energy efficiency of digital circuits. The most recent development in this journey is LVCMOS, or low voltage CMOS. This is a specific version of CMOS designed to operate at even lower voltage levels, such as 1.8 volts or 3.3 volts. This progression to even lower voltage levels has helped to further reduce power consumption and heat generation, contributing to better thermal management in electronic devices. But the journey of low voltage logic is not over. As semiconductor technologies continue to advance and as we push for ever smaller feature sizes and even lower power consumption, the evolution of low voltage logic will continue. It's an exciting field full of challenges and opportunities, and it's crucial to the development of the next generation of electronic devices. And that's how we've arrived at the state-of-the-art in low voltage logic. So, what makes low voltage logic different, and why is it so important? Well, the unique characteristics of low voltage logic are what make it stand out in the world of digital logic circuits. First and foremost, we have reduced power consumption. By operating at lower supply voltage levels, low voltage logic circuits consume less power, both dynamically and statically. This makes a significant difference, especially in battery-operated devices where power efficiency is a top priority. But it's not just about consuming less power. Low voltage logic also plays a pivotal role in energy efficiency. By lowering the operating voltage, the energy required to perform a specific task is reduced. This allows devices to perform more tasks using the same amount of energy, or perform the same tasks for a longer period of time. This is particularly important for portable devices, where extending battery life can greatly enhance user experience. However, it's not all sunshine and rainbows. With the benefits of low-voltage logic come certain trade-offs. One of the most notable is performance. While reducing the operating voltage can save power, it can also lead to slower switching speeds in the digital circuits. This is especially true in traditional complementary metal oxide semiconductor, or CMOS logic circuits. But don't worry, engineers are constantly working on innovative solutions to minimize these trade-offs and enhance the performance of low-voltage logic circuits. In essence, these key characteristics of low-voltage logic, reduced power consumption, improved energy efficiency, and certain performance trade-offs are what define its uniqueness and significance. It's a fine balance of power, performance, and efficiency. It's about making the most out of every electron, every bit of energy, to create devices that are not only powerful and efficient, but also sustainable. And these characteristics make low-voltage logic an essential tool in modern technology. From smartphones to IoT devices, low-voltage logic is everywhere. And it's not just because it's the latest trend. There are some pretty solid reasons why this kind of technology is making its way into our everyday gadgets. For starters, let's talk about battery-powered devices. These are things like your smartphone, tablet, or even your smartwatch. These devices have to be small and light, which means they don't have a lot of room for big batteries. So to make sure they last as long as possible on a single charge, they need to be incredibly energy efficient. That's where low-voltage logic comes in. By operating at lower voltages, these devices can significantly reduce their power consumption, effectively squeezing more life out of their batteries. But it's not just about making devices last longer. Low-voltage logic is also critical for managing heat. You know how your laptop can sometimes feel like it's about to melt when you're running a lot of programs at once? That's because traditional logic circuits can generate a lot of heat, especially when they're working hard. But with low-voltage logic, the amount of heat generated is significantly reduced, helping to keep your devices cool and comfortable to use. And then there's the Internet of Things, or IoT for short. This is a growing network of devices, from your smart fridge to your smart thermostat, that are all connected to the internet. Many of these devices need to operate in low-power modes, or even rely on energy harvesting. Low-voltage logic is perfect for these applications, providing the energy efficiency these devices need to operate effectively. Last but not least, there are wireless sensors. These devices are often used in communication systems where energy efficiency is essential. Again, low-voltage logic is the go-to solution, offering the low power consumption and heat dissipation these systems need. So there you have it. From your smartphone to your smart home, low-voltage logic is playing a crucial role in powering our modern world. Next time you use your smartphone or any battery-operated device, remember the role of low-voltage logic in it. Low-voltage logic may be a game-changer, but it's not without its challenges. Let's dive into some of the hurdles that engineers face when working with low-voltage logic. One of the main issues is maintaining signal integrity. When we operate at lower voltage levels, the signal-to-noise ratio decreases. This means that the signals are less distinct and more susceptible to being drowned out by noise. As a result, it becomes more difficult to accurately detect and interpret these signals. Engineers need to incorporate meticulous design strategies to ensure reliable communication, even in noisy environments. The second challenge is dealing with process variability. As we shrink feature sizes in semiconductors to microscopic levels and lower operating voltages, circuits become more sensitive to process variations. These variations can come from manufacturing inconsistencies, temperature changes, or even the aging of the device. This sensitivity can lead to significant variations in device performance and reliability. To overcome this, engineers must employ advanced manufacturing techniques and robust design principles. Finally, let's talk about robustness. Lower voltage levels can make circuits more susceptible to noise and changes in environmental conditions. For example, a small fluctuation in temperature or voltage supply could have a significant impact on the performance of a low-voltage logic circuit. To counter this, engineers need to design circuits that are resilient and can maintain performance despite these variations. These challenges, while significant, are not insurmountable. Engineers around the world are continuously innovating, developing new techniques and technologies to overcome these hurdles. They're exploring the frontier of low-voltage logic, pushing the boundaries of what's possible in our digital world. Despite these challenges, the benefits of low-voltage logic far outweigh the hurdles, making it a key player in our digital world. So, while it may not be a walk in the park, the journey towards low-voltage logic is one we're excited to continue.